In this video, we're going to begin our discussion with the addition rule and the complement. So we did a little bit with probability. Now we want to deal with probabilities where the events contain the word or the word not. All right, so let's suppose you select one card from a standard deck of playing cards. We want to be able to calculate the following probabilities. So the probability of selecting a heart or a black card. So remember, when I see the word or, that means I'm going to add. So it's the probability of selecting a heart plus the probability of selecting a black card. Now, the probability of selecting a heart, that's going to be 13 hearts out of 52. There are 26 black cards out of 52, which is 39 out of 52. Simplifying that, that's going to be 3/4. Now, is there any possibility of getting both a heart and a black card at the same time? And the answer to that is no, so there's no overlap for these events. All right, let's take a look at the next example. What's the probability of selecting a 5, a 6, or a 7? So again, we did this similarly before. This is the probability of a 5 plus the probability of a 6 plus a probability of a 7. So there's 4 5s, 4 6s, 4 7s. Add them up, that's 12 out of 52. And that simplifies to 3 out of 13. Now, is it possible to select a 5 and a 6 at the same time? No. Is it possible to select a 6 and a 7 at the same time? No. Is it possible to select a 5 and a 7 at the same time? And that's no. So again, there's no overlap here. Okay, probability of selecting a club or a king. Well, that's the same thing as the probability of a club plus the probability of selecting a king. Now, is it possible to select both the king and a club at the same time? The answer to that is yes, so I'm going to need to subtract out the overlap, which is going to be the king of clubs. Otherwise, it's going to be counted twice, one for being a king and one for being a club. And I can only count each card once. So there are 13 clubs, there are 4 kings, and 1 that is both. So I will subtract the 1 out of 52. That's 17 minus 1, that's 16 out of 52. And that simplifies down to 4 over 13. Okay, what's the probability of selecting a red card or a face card? Well, that's the same thing as selecting a red card plus the probability of a face card. Well, there's 26 out of 52 red cards plus. Now, what is a face card? That's either a jack, a queen, or a king. So 4 jacks, 4 queens, 4 kings. That's 12 out of 52. Now, is it possible to be a face card that is red? And the answer to that is yes. I'm going to have to subtract this out. I'm going to write it as a red face card. Well, how many of those do we have? The jack of hearts and jack of diamonds, the queen of hearts and the queen of diamonds, and the king of hearts and the king of diamonds. So there's 6 out of 52 that's both a red card and a face card. So that's going to be 38 minus 6, that's 32 out of 52. And that simplifies to 8 over 13. Okay, the probability of not selecting a queen. Remember, I'm going to write this out as 1 minus the probability of selecting a queen. So that's going to be what? 1 minus. There are 4 queens, 4 out of 52. So that's 52 over 52 minus 4 out of 52, 48 out of 52. Divide by 4, that's going to be 12 over 13. Okay, probability of not a spade. Again, I'm going to write it as 1 minus the probability of selecting a spade. That's 1 minus, there's 13 spades in the deck, so 13 over 52. I can rewrite it. That's 39 out of 52. And that simplifies to 3/4. So the general addition rule, the probability of E or F, that's going to be the probability of E plus a probability of F minus any overlap. So the probability of E and F. This would be the general addition rule I would use throughout this entire chapter and moving forward. Okay, disjoint or mutually exclusive events. These are two events that have no outcomes in common. Okay? Well, which of the following examples have we done earlier that are disjointed or mutually exclusive? Well, certainly the first example, because there's no heart that's black. Both cases can't happen at the same time. And in this case, if I'm only selecting one, I can't be a 5 and a 6 and a 7 together. Okay? So certainly 1 and 2. So how does the general addition rule change if the events are disjointed? Well, the probability of E or F would be the probability of E plus a probability of F. Well, minus both, that would be 0. So it would just end up being the probability of E plus a probability of F. And then the complement of E, looks like E to the C power, is all outcomes in the sample space that are not outcomes of E. So the complement rule that we will be using is the probability of E complement is equal to 1 minus the probability that that event will occur. And keep in mind, I can rewrite this as the probability of E plus the probability of E complement is going to be equal to 1. But this will be the complement rule that I will be using moving forward. Okay, let's take a look at the next examples. So the data in the following table show the results of a national study of 137,243 U.S. men investigated the association between cigarette smoking and death from cancer. If an individual is selected randomly from this study, calculate the following. So what's the probability that the individual never smoked cigarettes and died from cancer? So the and means it needs to be both. So how many people never smoked cigarettes and died from cancer? Well, here, that is going to be 782. So let me write this out now. So it's the 782 over the total, which was given in the problem, 137,243. Keep in mind, as these numbers get bigger and bigger, I'm not going to worry about reducing the fractions in the lowest terms. All right, let's take a look at part B. What is a probability that the individual did not die from cancer or was a current cigarette smoker? Well, remember the or means I'm going to add them, so let's take a look at the table. So did not die from cancer, that's here, here, and here, or is a current cigarette smoker. Well, I'm not going to count the 7,725 again, but I certainly need to include the 141. Okay, so let me write this out now. Okay, so setting it up, we get 136,370 over 137,243. Which, by the way, if you wanted to do as a decimal, that's approximately 0.994. But for these probability problems, leave them as fractions reduced in the lowest terms. Okay, one more example then. What's the probability that the individual selected was either never smoked cigarettes or was a former cigarette smoker? Okay, so again, I see the word or, so I'm going to add them. So never smoked cigarettes, that's the 782 here and the 120,747. Was a former smoker, that's 91 and 7,757. So I add all of those four numbers together over the denominator. So let me write that out now. Okay, so adding 787 plus 120,757 plus 91 plus 7,757 gets me 129,371 over the total, which is 137,243.